And I am now recording. Let's see, today is Wednesday, September 4th, 2019, and this is the regularly scheduled meeting of ITSE 2309. And where is everybody this morning? It's the day after a holiday, and that means everybody takes a day off, right? I guess they'll come dragging in here. How many do I have online? What I'm thinking about doing is moving the class, this class officially meets Monday, Wednesday. I'm going to ask if we would like to change our meeting times, and everybody would have to be a part of it, instead of Monday, Wednesday, to meet Wednesday from 11 o'clock to essentially 2 o'clock. I will be here on that day. I'm here anyway. I could be available on Monday for questions, but I wouldn't have a scheduled meeting time. What do you think? You're the only one here that's part of the face-to-face class. How do you feel about that? At 8 anyway. What? Yeah. Sure. I don't get here till 8. I don't get here until about 10 most of the time. But what would change, instead of being 11 o'clock until 12:50, we would meet from 11 to 12:50, and then have lab from 1 o'clock to 11 to 12:50. From 1 o'clock to 2:50, wouldn't it be? So 11 to 12, 1, 2. So at 2:50 we would finish lab. Now you don't have to stay for lab, right? Once we finish lecture at the regular time, you're free to go someplace else, go home and work or on your stuff. But I'll be here in this room after that. I'm interested in getting some feedback. That would stop you from having to come to class on Monday morning at 11 o'clock, instead of making 2 trips for this class. You just make 1, if that is an option. Did you hear what I was talking about? We're talking about possibly moving the Monday morning class to being a lab, so having a 2-hour lab on Wednesday. I'll do that today. Excuse me, a 2-hour class. Go ahead, please. You have a 1 o'clock? Okay, well, we'll, okay. Anyway, let's look at what we had there. This was a guided practice, and use SQL to create 2 tables. This looks a lot like a test question. Doctors and patients. A doctor has a unique identifier, a name, address, street, city, state. That should be 3 fields. A phone number, and 0 or more patients. A patient has a unique identifier, a name, an address, street, and exactly 1 doctor. And so the way this is going to set up, pull this up. Here is my solution. Okay, all good table creation scripts. All programs will start with the database to use. So this one's going to use ScratchDB, Scratch Paper. If object ID patients is not null, drop it. So remember, the patients that a doctor has 0 or more patients. The patients is the child, the doctor is the parent. Therefore, the patients gets dropped first. Must be that way. If you try to reverse them, it won't work. If I drop the doctors first, I would have invalid references. Hello. So I drop the patients first, then I drop the doctors. The doctors table, once they're, and a good creation script should have these lines in it. This is not SQL. If then else is not SQL. Naming variables is not SQL. There are things that Go is not SQL, by the way. Now, before I do the create, this Go right here is optional. It's not needed. It doesn't matter whether you have it there or not. It doesn't do anything. We should have a Go before the create, Go. Then we create the table. Then after that, we have another Go. So this create table exists in its own little batch program. That's what Go does. It breaks it into two different programs. There's no reason to have just Go, and then when we start selecting data from tables, there'll be no reason to have the Go between each one of them. Only for create. And we'll see other creates. Okay, so we create the table doctors. I always put the primary key first. I always put the primary key first. Notice my naming convention. It is terse to the point, SSN, name, STR, street, city, state, phone, and I put the D underscore on them to show me that they begin with the doctor's table. That you don't find, not every database person will do that. I try to do that so that if I look at that name, I will see that it belongs to the doctor's table. Then after that, I do my constraints. There is nothing special about this order. This is the order that I put them in. I put my primary key first, and then after I have defined all of the fields, I put a dash dash. We should not have an empty line. Some databases, not SQL Server, some databases have a problem when they hit an empty line. Okay, so we won't use them. We'll avoid that because Oracle will error out if it has an empty line. So I like to try to teach this class to be as generic as possible. Then after that, I put my constraints. The first constraint, and I give it a name. Okay, it is possible, and you will see databases where they will say DSSN char 9 primary key. Yes, but that constraint doesn't have a name, and it is difficult now to work with that constraint later. If I have the constraint named, I can drop it or recreate it, or some of them I can turn off and on. For example, the null name, I can disable that one, and then I can put a null name in there. Okay, so primary key is DSSN. It is possible to have a primary key that is more than one field. We won't do that right away, but we'll see that there are some in our AP database. Then a comma, another constraint, null dname, check, dname is not null. That's a check constraint. There are others. I can say check that value 1 is less than value 2 if value 1 and value 2 are both in the same table. I can say check that. I can check anything about the data that are in that table now. I can't go to another table with a check constraint. No comma at the end. Some of them will allow you to have a comma at the end. In general, SQL gets fussy about commas at the end. Let me see what happens if I put a comma here. Okay, it let me have a comma there. SQL Server is sometimes a little promiscuous about what it will accept. By the way, you see the output screen down here? My screen is now split, and I have an output screen out there. If I press Control R, I close that and open up the screen where I can see more of the. So if I execute it, that output screen is going to stay there. To close that, Control R is what closes it. I'm also free to close this Object Explorer If I need to have more room, I can just close that guy, and now I've got the whole screen to look at. If I want to get the Object Explorer back, I go up to View, Object Explorer, and it comes back. So this is the way I usually run. All right, so I've created the doctor's table. Now I'm going to create the patient's table because the doctor's is the parent, the one side is the parent, the many side is the child. The child is dropped first, the parent is created first, always. Create table patients, the child. Again, I begin with my primary key. I will usually name the primary key either PSSN or if it's patient, either SSN or ID, and I'll put the first letter of the table. If I have too many tables where I can't get, some of the tables might have the same first letter, I'll take as many letters as I need to get a unique field name. I like unique field names. Even though I can have duplicate field names in duplicate tables. The field names can be duplicated. Okay, so I got the SSN, the name, street, city. The order that you put these in is your own business. And then the last one, DSSN. Right, that's the foreign key. So I always put that last. I put my primary key first, then I put my foreign keys last. Nothing special about that order. That's just the way I do it. Okay. You should develop a way that you do it. It might be like mine, it might not be. But as you develop a way that you think makes sense to you, it's easy to write really difficult SQL code to understand. And you should try to write stuff that is easy as possible to read. Okay, constraint is the primary key. Now take a look at the constraint of the foreign key. Pull that down. Patient, this is the name of the constraint, patients underscore doctors underscore FK. The reason I named it that was because that tells me something about what the constraint is. I could have named it X, but that wouldn't have told me anything. If I violate that foreign key, I will see that name as part of the error message. Okay. It's a foreign key. What is the foreign key? DSSN. Wait a minute now, we have a duplicate field name. Which one of these is it? Well, it's the DSSN in the patient's table that I'm talking about now. That is the foreign key. References a primary key. So a foreign key will, I'm going to lie right now, a foreign key always references a primary key. That's not true, but you can pretty much take it to the bank. If it doesn't, there's a reason. It's weird. Okay, it is possible. I can make the key, I can make anything a foreign key referencing anything else, but it doesn't make much sense unless you have a primary key being referenced by a foreign key. It is possible to do something different. We're not going to do it in this class. And it would be really, really weird in any setup to have it. Because think about it, what would it mean if my IQ referenced my shoe size? That would mean that I could only put in IQs that I had a shoe size for in the table. So, if I'm size 11, that's the highest IQ I can put in. It doesn't make any sense because they have nothing to do with each other. So the two fields have to have something to do with each other. So the doctor's primary key over in the patient's table means that that patient is associated with that doctor. The last go is optional. The semicolon at the end of the SQL statement, SQL Server will let you get away without it. However, I won't, okay? So use semicolons at the end of each statement, not at the end of each line. Commas separate the lines. This is one statement. Spaces outside of that statement are fine. Empty spaces outside of the statement are fine, mean nothing. Empty spaces inside of the statement, empty lines inside the statement should be avoided. Put a comment on the line. The last go is optional. I will generally put it there, don't have to. I will generally put it there because lots of times I'll come along and put something else at the end, and it really makes a mess. Okay, questions? That was the guided practice, and I gave you this. You have this file in your Canvas. Questions? I don't see any chat. Questions online, people? Amanda, do you still hear me?
Yes.
Okay. Well, I'm going to move on then. Let's see, modules. Okay, let's put data into these tables. So after creating the tables are all created pretty much the same way. Yes, there is more to it than that. I don't know why lots of the textbooks start off with existing tables and you just start throwing data at them. To me, that's the wrong way to do database. All of the books do it that way, though. They start off with using select statements, select from where, and retrieving data from the tables that are already in the tables without you having any idea how the tables come into existence and how the data get in the tables. I always start with creating the tables. Then I start with how do you know the basics of putting rows into the tables using SQL. Yes, you can use the graphical user interface. Yes, that Object Explorer will let you create tables just like you did in Access. Yes, that's usually there. But what if it isn't? This is a class about SQL, and we should be creating the tables in SQL. I don't care how you create the tables in the real world. I mean, if you do it with a graphical user interface, that's fine. But you're going to have SQL at some point, because if you're interacting with your database using a web server, you're going to have to write SQL code that manipulates the data. So this is a class about SQL. I'm going to try to keep it as pure SQL as I possibly can, meaning I'm not going to bring in anything else to the extent that that's possible. Of course, Go isn't. Data manipulation, let's start with this one. Okay, SQL statements fall into two fields. One of them is called data definition language, and when we create tables, we are defining our data. In other words, if this were a card catalog, what I would be doing would be defining what one card looks like, one card in this guy, because they all have to be the same. It doesn't make any sense to have a card catalog of cards about my rock collection and cards about my friends and notes to myself. I'm just going to have a big hodgepodge of it looks like my computer disk. But in a database, it keeps it all organized. So everything, all of the fields have to look the same. Not always true, but they have to look the same, at least for now it is. So when I'm creating tables, I am defining the data definition language, create. Sometimes it's referred to as DDL. So when you're creating things, you're defining the data. Now we have come along here, and create database, by the way, is also when I change data, when I insert and update and delete the data, so I put data into the table, change the data that are there or delete the existing data. That's called data manipulation. So it's a little bit different. So maintaining the content. And that's going to be in chapter 7. Okay, I didn't tell you to read the whole chapter, but do read those parts of it that I gave. Okay, I'd say I'm going to approach it by way of example. So here's an example. Insert. Copy, and I'm just going to go back over to this guy. Now, this is why I always put a go at the end, because I'll always come in here and paste something else after it. Now, what would happen if I didn't have that go? And it's one that people forget. I'm going to make you put it there because you get an unpredictable error. Sometimes it will hiccup and you'll give you an error when you try to insert, and sometimes it won't. I'm going to try it and see. Execute. Okay, everything worked. I can try it again because I'm dropping the tables each time. Okay, it's working. Nonetheless, we should have go. Most of the time it does work. Control R to get to my. Most of the time you don't have to have that go at the end. It's just that when it doesn't work, it really doesn't work. And I don't know why. I don't know what it is that causes it sometimes to work and sometimes not to. We're going to use the go. Okay, this is insert into the name of the table. And remember, I have to insert doctors first. I can't insert a child before I have the parent. So insert into doctors. Now, you will see sometimes people will drop this second piece of it. Sometimes they will. They should not, in my opinion, because that gives you the order of the fields that they're going to be. If you give it the data in the order that you created the table, it will accept it without that line. But having that line means I don't have to remember in what order they were created. I'm free to mix and match. I'm free to change it. I can put DSSN last if I want to. I just have to make this, the values line, match this line. So these two lines have to match. Where I say I'm going to have a DSSN, I have to have the DSSN there because that's where it's going to end up. Where I say that it's the date, the state, excuse me, the state has to be in that position. I cannot have anything. I can only put in some of the things. For example, the only thing that is required is SSN and name. Okay. Now I don't have to have a go between the inserts. I'm only going to put in SSN and name. Now I cannot have the same. If I tried to put in that, I'm going to get an error. Because and the nice thing about this is I can just highlight just that one piece. So I want to try to insert it. Now it's going to give me an error. Why will it give me an error? Primary key, doctor's PK, cannot insert duplicate key. Remember what we said, primary key must be unique. Okay. So if I make it be unique, put a 0 on the end of it, that'll make it. Now it will accept this because DSSN is required, DNAME is required, but that's all. So it will accept this as a valid row in the database, and it says everything's fine. What about, well, what about the city and the state and the street? Those are just null. Now, most of the time, if I write a database, when I create a database to work, I will typically constrain everything against null. No nulls allowed. And what I will do, I will give it a default value, and I'll show you how to do that. So I'm going to say, well, your salary, you must have a salary, but what if I don't give you a salary? I can cause it to default to 0. Okay, that's better than not having one. Nulls give us lots of trouble. Nulls are one of those things that are difficult, because what if I wanted, okay, we're going to have a party and you have to be 21 years of age to come to the party. So I sort the class and I say, okay, show me all of the people who are under 21. Okay, so I get that group. Over 21, 21 or over, greater than or equal to. Get that group. Well, what about someone for whom I do not have a birth date or an age, whatever? If it's null, they will not appear in either set. So you'd think, well, if these are less than 21, these are greater than or equal to 21, not having a birth date has to appear someplace. No, it doesn't. It won't. So we have a saying in database, nothing gives us lots of trouble. We don't like nothings. Most of the time, I will constrain my fields against nothing. I just demonstrated that this is how you would do it. I would have, let's see, how many fields do I have? One. I don't need to constrain the foreign key. 1, 2, 3, 4, 5. I would have 5 not null constraints. I'd probably put them all together in the same order so I could find them easily. Sometimes these create tables get kind of long. Notice that there is nothing stopping you from having an orphan in this setup. And what is an orphan? No parent. So there's nothing that's stopping me, but there's no database reason why you have to have a value in the foreign key. A foreign key, remember, this is an important point. A foreign key can be null unless you write a constraint that says it can't. In that case, it can't. So it depends on your needs, your database. Are you willing to accept orphans, or will you constrain against them? In this case, it does. Okay. Go back to my, it is possible. Let's see, 4. I'm gonna run into some trouble there because I'm trying to, I've got a duplicate for this primary key matched one that was in this group. The second one allows me to not have to duplicate. Some databases, most databases, modern databases today will accept this. I can think of one offhand that doesn't. MySQL does not accept this format. You have to say insert into doctors, yada yada yada, you know, and then so you have to do them one line at a time. But copy and paste is your friend. It doesn't cost no skin off my nose. But you can do it this way. You can just have one insert statement. The bad part about the one insert, maybe it's a good part, maybe it's a bad part, something you should know. If anything in that insert statement fails, it's all rolled back. Okay? Nothing goes. So it either all goes or it doesn't go. This might be good, it might be bad. If you look at, I think in my script that I made that creates the AP, and I believe we did that, right? We have created our AP database, I believe. If you look at my script, I think I used this guy where I stack them up like that. I don't remember whether I did or didn't. Some I may maybe do, some I don't. Okay, so here's a notice that the name Bill, the name cannot be null, but duplicate names are perfectly allowable. The only thing that cannot be duplicated is the primary key. So this primary key has to be unique. Questions? Okay. Here is insert statement supports fewer than all fields. I've already done that one. Don't have to have them all. You just have to have the ones that are required. So the primary key is always required. In this case, the name is required. The other thing I can do, if I don't want to put them in, I can make them required anyway, not null. But if I give them a default value, let me put a default value in. Okay, the doctor's name. I'm going to give the doctor's name a default value. His default is Fu. If I don't give you it now I can put in a doctor's without a name and it will default to that. And it doesn't tell me much, but if I find that name, it probably means that I just didn't have a name. So what I would probably do instead of that, I would probably give it something that you can't have a name. I tend to give it a tilde. Nobody's named tilde. I mean, they might be named TILDA, but nobody has that name. That's punctuation. So you can't have that name. But that's what I give you if you don't have a name. That's the name I give you if you don't have one. So sometimes I'll do that with, I will default the SSN. So I'll put an SSN up there, 0000000. Nobody can have that. And then my foreign key is required, but it defaults to that 00000. Okay, so that means that when I always require a parent. But if you don't have a parent, you can still be put in the database. I just give you that particular parent, but I have to have that record in my parent table. Am I making any sense at all? Yes, no? No? I would insert, I would do an insert like this. Paste. I would insert zeros. Parent, and I might say parent of orphans or something like that. Foster parent, maybe, I don't know. And then when then I would set the patients, the foreign key, to that. Then I would constrain the foreign key against null. So you cannot put null in there. But if you just don't give me a parent, I automatically give you that one. That's very common to do that. Go back over to here. There is no required order to the field list so long as the values list matches it. Now that's why we always use the field list. So Okay, let's see. We're going to put in patients now. So I have, where am I? So I have put in, it's perfectly okay to have empty rows down there. I don't like lots of empty real estate in a file, but it's okay if you put the empty rows down there. So I'm going to insert now into what? Patients. What? Patient social security number, patient name, street, city, state, and their DSSN. Now, DSSN must exist in the doctor's table. Okay. If I try to put it in and it doesn't exist, I'm going to get an error. So this is going to give an error. I'm going to try and notice that the name of the constraint was part of the error message. I won't always get error messages that are this nice. This tries to tell me a lot about it, but they won't always be that nice, and I need that piece coming back. So I will always, whenever I name a constraint, I name it a lot. I name it something that tells me something about it. I'm not going to type it very often. So I don't mind long names for constraints. So it terminated, but if I go in and fix that, and I get now I have one that's in there, now it will accept that. I got a successful. By the way, it gives me a count, one row, one row, one row. There's the one that has the 2 on it. And then this was the insert into patients. So I can insert as many patients as I want to, as long as I have different primary keys for the patients. So I can have another patient that belongs to Dr. ID 447458999. I can have 1,000,000 of them, or I can have 0 of them. Okay. There's some further information on that. The most common mistake that students make here is they try to insert the patients before they have the doctor parent, or they try to put a different a doctor ID into the patient that does not exist in the doctor's table. That doctor ID must exist in the doctor's table. Okay, and I jump up and down over that and all this, that, and the other. Students will still do it. I've learned I don't get offended at what students do. They will. Oh well. And then I send it back. This is why I like to get the papers, get your information up front. Okay, some notes to point out. In SQL, strings are always single quotes. Double quotes are never used in SQL. If you might see me write a double quote someday. If you do, say, Dr. Smith, you're writing C code again, or Java or something. That's not SQL if it's got double quotes in it, single quotes. SQL is not case sensitive. However, it is a good idea to treat it as if it were. Notice that I use uppercase. I use uppercase for reserved words. They turn blue because that's the way the editor is set. When it sees a reserved word, it turns it blue. I use uppercase for those. I use lowercase for others. Now, You can use the underscore as a space if you like. What? Am I getting? Oh, somebody's calling. Okay, thank you. Okay, what can you set different values for different fields? Let's see. First of all, can you set different values for different fields? Yes. Do you mean in? I'm assuming that you mean in something like this one. Say again. It should be okay if the these are different default values. Yes, of course. Yes. It will always be the same default value for that field. For example, if I say that the default value is 00000, then every time I do not provide a value for that field will default to 0000. So I can't have it default one time to something and then default a different way a different time. So default value is pretty much set. But for different fields, I can default all of the fields except the primary key. I can't default the primary key because he has to change each time. So, but the rest of them can be defaulted. Something, okay, so Liz is saying it should be okay if the default value for phone number or something like that is used. Name seems like a confusing example. Okay, I'll buy that. Name is a confusing example. Just the only reason I did it was because name was required. Name was constrained against null. And I would probably try to take something that nobody can have this name, so I would know when it was defaulted. Won't there be a problem if more than one doctor has the default value? That is not possible, because remember that the what I'm defaulting is a foreign key that's going to a primary key, so only one doctor can have that default value. It is a primary key. So I put this special field in there. This, I call it parent of orphans. And by putting that field in there, only one doctor record can have that. So anytime it's there, that had to be the default. If there's any further questions, okay. If I don't have that, you can send me another one. Thank you for keeping an eye on that for me when they pop up. You can use the underscore, okay? This is commonly found in Java and in C. It's the way they do it, okay? Here is another option that this works just fine. This is called camel. Camel case, where you don't put any spaces and you just by your capitalization scheme, you show what it is. So, camel case is where you mix uppercase, lowercase. Now, SQL doesn't care. So if you just spelled it all in lowercase or all in uppercase, it would be the same identifier. No, with lots of exclamation points after it. It is possible, and you're going to see it, that people will do it. Don't do it in here, please. You can use spaces in a field name if you put it inside of square brackets. And if you want to see me throw a fit, Just do that. The reason that we don't do that is not because I don't like spaces, but it's because it will make your code and your database be incompatible with many other platforms. You will regret it if you do that. Now, I have a way to say, oh, to name the field. I can name the field, D_name, and I can show it to you as Dr. space name. That's easy. I just don't show them that name, show them this name, and I just give it an alias and put spaces in that. That's fine, but don't put any spaces in the name of a field. Okay. Whether you choose to use, do you like camel case or do you like using the underscore? That's your business. Sometimes people will change back and forth that has different meaning to them. I can read it just fine either way. So it's kind of your call. If I don't tell you what to name a field, you get to name it anything you want. If I tell you to name a table something, then it is important that that table be named correctly. The fields inside of it are fine. Sometimes it'll become important and sometimes it isn't. It just depends on, is another program coming along expecting to find that table named doctors plural, and if you name it doctor singular, it won't find it. So we're a little fussy about names, but we don't like this one. We don't like using spaces with also, I think you can put it in double quotes. I believe that's a use for double quotes. I think double quotes works. I don't know, because I don't even want to touch that. Let's see, it's about break time. The SQL server does not require the semicolon, but if you move to another platform, it will. And ideally, what I'm teaching here will apply to Oracle, it will apply to MySQL, it will apply all of them. So anything that I've done here, with the exception of Go and the if exists, if is not null, then drop it. Isn't SQL. So those will change. They'll be sort of the same thing, but they will change. Some decent reading here. Next, what else have I got? Okay, update. Questions on insert?
Hey, Dr. Smith, I have a question. Would it be worth noting at this point that for the single quotes, if you have to insert a text that has a single quote in it, such as apostrophe, that
Yes.
you double that single quote?
Yes, it probably is. That's if you do single quote, you get one single quote. Yes. So if your data include single quotes, I think there's some way that you can do it also with the square brackets, but I'm not, since I don't do that. Yeah, it would be worth noting that if you're trying to insert a single quote, you double it up, and the first one escapes the second one. Yes, thank you.
Okay.
Go ahead. Okay, N in front of it, yes. Is it something it's in single quotes or double quotes? Is it not working or what? Oh, okay, the N in front of it in the Create AP SQL. I don't want to take that on right now. The N, it says it's an N varchar, and that means that it uses a different character set. So you can have Korean characters or Japanese characters or Arabic characters, we're going to have a whole chapter devoted to that idea. So yeah, right. I don't want to get into that leading in for right now. Just if it works, it works. Okay, let's see. It's 11:49, so that means it's about break time. So let's take a short break. I need to run to the bathroom, and ordinarily I would be ending now. Okay, since I've got your attention for a moment, and you guys that are here today, I know you're saying you have a 1 o'clock class. Okay. What I'm asking about is what about running this class until 1 o'clock and then lab following it? In other words, having this class run 2 hours lecture and lab following it, and we can be creative with the times on the lab. So I would be here for that 2 hours. Now you don't have to stay for the lab. And I'll discuss. So tell me what you think about that. And I'm gonna turn off the recording right now. So I'm gonna run to the bathroom. Somebody remind me to start the recording again. So I'm recording now. Yes, ma'am.
So if we make a default value on the table.
Just a minute, my phone's ringing. Okay. Well.
And said we already inserted like one table, but most of them are all default. Update on that.
You can update the table because they will have values. So if you make it a default, it's going to take its default value. You cannot update it to null if it says no nulls. So the nulls will stop you from putting a null in there, the no null. Update. Database programming is very unforgiving. And I say there because changes are written to the disk as the code executes. So it saves everything. It doesn't, if you are in a spreadsheet environment and you're going along, the spreadsheet is writing it to memory and then putting it in. When you say save, the spreadsheet puts it in. In database, you don't usually have a save the database. Once you insert, it happens right then. When you create the table, it happens right then. It's not written to some buffer someplace and then put into the table. Now that's not always true. Sometimes it goes into a space on the disk that's a buffer, and that's known as the rollback segment. But for the most part, you think of it as happening immediately. Therefore, database does not typically have an undo. Now you can log everything, and there's some ways that you can get back to a previous position. But by and large, it's a very long process, and you have to be very careful with database. So let's see, updating a row. If you update, you can update more than one row very easily. Let's see if I can. Here's some examples. I don't know where I got this. Let me see if I do one here. I don't need these anymore, so I'll get rid of this. Okay, I've got some, let's see. Doctor named Bill has changed his name to William. So if I say update doctors, I usually go to the next line, set dname to William, where DSSN got two quotes there, but okay. So what am I saying? I'm saying change set dname to that where DSSN is William is that number 447458999. So it was Bill. Now it's going to be William. When I execute this, I'm going to change that record. Execute, one row affected. Now, if I want to see it, I'm going to execute this. This is the next chapter, by the way. Select everything from, so this is coming right up, the select statement. Select shows us the data. So if I say select from doctors, show me everything in doctors. And if I execute that, notice that the 447458999 has been changed to William. The others have not. Okay.
And if you need to change the primary key?
Very seldom, very seldom will I ever change a primary key. We select the primary key for the reason that it does not change. We don't like to change primary keys. For example, try going down to the Social Security office and telling them you're tired of your Social Security number. You want another one. They're not going to give you another one. You're stuck with it. Same thing with your driver's license number. So things like that, they typically don't change. And that is why we chose it as the primary key. Now, can it change? Yes, it can. But remember, a primary key is so very important, and we don't really care. I told you that a database, the rows in a database have no order. Well, that's not true. They have to have an order, you know it. So they're sorted by the primary key. If you change the primary key, you're changing the sort order of the whole database. So now that record has to move someplace else. This is not good. Okay. I mean, it's expensive. So suppose that instead of like that, I had highlighted just this piece. Suppose I had highlighted just that piece. Are you with me? Look, just that piece. And now I'm going to execute that. I don't have the where. Now, this is why we don't like, I don't like databases that execute where the semicolon is optional. I like it having to have that semicolon. In other words, I have to put that thing there that says, that's it, I'm done. Okay, I'm not done yet, but let's say I accidentally executed that. Notice that I have impacted 5 rows or 5 million rows. If I had 5 million rows in there, I just changed 5 million rows. And if I select it and I go in and look at it, what did I do? Oh no. Oh, that's called a resume generating moment. Okay. So I've accidentally impacted far more rows than I wanted to, and that is quite possible to do. And I did that just by I accidentally highlighted that piece and then I executed. And you have to be incredibly careful with database because it is a very unforgiving environment. Now, what can I do? Well, I can, like I say, I get my resume ready. A person who is database, it's like it's like being a professional driver. Nothing is going to stop you if you just drive your vehicle into a bridge abutment. It's going to be very bad. And it's very easy. You have to keep your attention on what you're doing at all times. So when you're driving a car or a vehicle, just like that, you have to keep your attention on it at all times. Now, what can we do in our database if you trash your APDB? Oh, well, all you do is run that script again. It puts it back. That's easy. But that's a small database, and where we have the luxury of just recreating the database, nothing to it. But if a database typically is big, and if I have to go in and restore it from my log tapes, that database could be down 2 or 3 hours. Okay. Well, some place like a big database that's in a lot of use, you know, it's hundreds of dollars a second that your time is worth on that database. So fortunately, because I can put it back easily just by running the script again. Okay. This is Smith. Hello. Why do you call me twice if you don't want to talk? Okay, and let's see. So in update set William where, so it will set any of these. I could say set where DSSN is less than that. I can say set it where I can update multiple rows at a time. You have to be very careful with update, because I just wanted to cover it. So basically, where update is going to be pretty simple. If I change the, let's see. Well, let me go back here and see what we got. Okay, well, this is a fairly good, this shows the update customers. Usually when I update, the where clause has the primary key in it. I like to do it that way. It doesn't have to be that way, but I try to do it that way if I can. Next. Deleting rows. Again, the same thing, deleting rows, deletes. Delete from the table name. Where the column has something. Usually I'll go for the primary key. So for example, going back to this one, if I wanted to delete, so delete, D-E-D. What?
We delete the value we can know.
I'm sorry, I don't understand. Ask.
When you delete the value we can just know.
Oh, when you delete the whole row.
Oh, the whole row.
Yes, delete deletes rows. Delete deletes the whole record. If you wanted that value to be null, you have to set it to null. Okay, so set such and such equals, and in that case you would say equals null because you're assigning null to it. And so you would put a null in there. Now I can't put a null into the name because it's constrained and it'll stop me. But anything else I can make null using update. If you say delete, delete from doctors, where the DSSN is that, remember that's a Williams DSSN. If I execute that, okay. Why can't I delete that record? I'd forgotten about that. What?
You're leaving an orphan, right?
I'm leaving, no, an orphan doesn't hurt me. I would be leaving a invalid reference. Okay, so before I can do that, I have to say this: delete from. This is not a safe thing to do, where okay, delete from patients. Now this is very likely going to hit multiple records, because they might have, I forget how many, I don't know how many patients I have in there. When I execute this, and I can execute them both together, execute, and now I have deleted the child, only had one, and I deleted the parent. And if I were to go look at it, select from doctors, I'm going to find that that one is gone. William's not there. If I were to go delete and look at patients, the child would be gone also. Usually I do not delete. Very seldom do you delete from a database, from a true working database. Almost all of the time, I will disable the delete command completely, not let you delete. If you take my next class, you'll see examples of that. If you go to see a doctor and that doctor treats you for whatever, they do a physical, whatever, you are in that doctor's database. If you no longer see that doctor, does that doctor delete your records from their database? No, never. Okay, they'll keep them forever. What about your records at Collin College? If you graduate from here or don't graduate from here, leave, whatever, will your records be deleted? No, never. Okay, we have, I don't know how long Collin College has been here. Collin College has been around actually for a long time as a community college. I think it's like 40 or 50 years old. So that means there's students that have died, probably. I don't know any, but their records are still here. Their records are still in the database. So usually what I will do is I will never delete. I will just have a field in that record that is like it's either 0 or it's not 0. And when that record is deleted, I will set that field to 0. And if the record is active, I will set that field to 1. Is the way I will usually do it. And then later we'll see how I say, just show me the active students. The rest of them are still there. Okay. Okay, deleting. Oh, one other thing. Here's the bad one. Delete from doctors. I highlight that. Like I say, you have to be very, very careful when you execute. 4 million rows affected. Oops, I just deleted that whole table. This is why I like it not to execute until I give it the semicolon. If I want it to execute, I'll put a semicolon on it, but this database does. We have to be very careful with it. And if I go in and look at it, I don't have any data. Oops. Okay, that's why I'm very, very careful. I have the ability in my database not to allow people to do that. And in fact, that's the topic of the next class, is how can I stop people from making a silly mistake like that and clobbering millions of rows. So I can stop you by my code, where I don't let you execute a delete. I make you do it through my code, and where I check it and make sure it's doing something that's okay, then I'll do it for you. So most of the time that a secretary or something of the college does not have the ability to delete a student from the database. Not because I don't trust the secretary, but because I don't want to expose her to that kind of a problem. Okay. Now let's see, it's 12:12. Let's look at what we've got. Notes on delete. Here I'm talking about what we do instead. We create our records like this, and so this table is named demo, and it has a record in it called deactive, and it defaults to 1. It's an integer, and it defaults to 1. And now if I want to delete that record, instead of deleting it, what I would do, I would update it and set that one to 0. And then that record would be effectively deleted. I would know that it was no longer active. And so if I say, show me all the active ones, I'd say, show me the ones where that field was 1. And then if I wanted to find an inactive record, I could go back and find it just very easily. So select from where, here's the select from where. We're going to do the select from where next. So most of this class is going to be about select something from a table where something exists. So we're going to be mostly concerned with that. I don't want to go into triggers right now. That's completely next class. I'm not sure what I'm doing here. Create table with insert. I don't think I'm going to do that slide. These are just demonstrations of update and delete. Discussion. And here's the assignment. Okay, the assignment is going to be, it is okay if you put both assignments into the same file. So the assignment to create the pets and owners. So I had you create pets and owners for the assignment from module 3, and now we're going to put some data into them. I'm going to grade them all at the same time. It is okay if you just write it all in one file, but I would like to please if you would turn it in to both. I need to get an assignment before you go in my queue to grade. So if you put them all in one and you only put it in for module 4, I won't have anything that says put a grade in for you for module 3. So it's okay if you want to turn in the same file for 3 and 4, then you can just put them both in there. That's fine. But so when I grade module 3, they're in there, and then I can just grade module 4 and they'll be in there too. So one of them I'm going to grade if it's turned in for module 3, I'm going to grade the create table. If it's turned in for module 4, I'm going to grade the inserts. When you do it, always run your code. So when you finish with it, if you say execute, it should execute without errors. If you're getting errors, figure out what's wrong with it. Get in touch with me. Come to lab. Okay. Okay, I'm going to wrap up there. It does not look like we are going to be able to get the do the the Wednesday only class. Now I will be here after class on Wednesday. So after we finish, I will be around here because I have a class later on in the afternoon. So I'm going to be in this room. We don't have a class meeting here. So if you need to find me, here's where you can find me. So I've got the advanced class later on in the afternoon. So I don't leave. Okay, we're going to wrap up there tonight. The next assignment will be Module 4. And I guess I can go ahead and make that assignment now. Let's see, that would be due. Okay, if it's today is the 4th, I'll make it due on the 11th. And you have until the 18th. Okay. Now, so when I grade it, I'm going to grade Module 3. Guess I'll do that probably today and get that back to you. If there's a problem with it, I'll get it back. I see I have a bunch of them in there to be graded, so I'm going to get right on that. So we're going to go ahead and wrap up today. I don't think we're going to, like I said, I don't think we'll be able to change the class meeting times. I think that would just be dangerous to try. If I just have a very, very tiny little class and only have 3 or 4 people in it, sometimes I can do that, but I don't think it'll happen this time. Okay, so we'll break to lab now, and I'll be here. Questions from the, okay, somebody's here. Let's see what's happening. Won't there, let's see, where is it? From 12:09, here we go. Are both assignments due at the same time? Never mind. Let's see, the assignments, I think they probably should be due at the same time. Let me see what time I've got 3 due, I think. Let me double check what time 3 is due. Well, Module 3 is due September 4th. Module 3 is due today, and that's fine. Module 3 and Module 4 time out at the same time. So that would be September 18th. So and that's fine. I like it that way because that gives me time to get them graded to you. So they're both going to be active for another 2 weeks. Amanda's question: are they due the same day? No, they're not due the same day, but that's fine if they're not. I'm not too worried about that. So you can turn them in as you get them. The sooner you get them turned in, the sooner I'll get them back to you. And if there's a problem, you'll be able to redo them. Okay. Okay, I'm going to end the recording here.